Hey there, Chem Squad. In today's class, we're going to look at how to solve a type 4 equilibrium problem. So for a type 4, this also requires a ICE table, um, but there's a bit of a different scenario here, okay, in terms of how we fill it out. So let's just take a look at the type of question this actually is and how you might be able to recognize it. So in a type 4 question, you're asked to find the equilibrium concentrations, okay? Um, but you only have the initial concentrations given, okay? What's also different from a type 3 is that you actually do have the KEQ, okay? So that's going to play a role near the end of the process here. So just like with all your other problems, you always want to start with step 1 and check to see if your equation is balanced. And in this case here, we do have a balanced equation. So the next thing you want to do is you want to check for molarity. So you can see right here that you're given everything in moles. Okay. They tell you that the reaction vessel or the flask that your reaction is carried out in is 20 liters. Okay, so you're given a volume. So since you have moles and you have volume, molarity is basically just N over V. So you can calculate molarity because it's not given to you. So if we do a quick calculation here, it'll be 2 moles over 20 liters, which equals 0.1 molarity. Okay, and this is for the reactant, which is HBr. Okay, so because they're describing this at the beginning, that means that this is an initial concentration. Okay, you have KEQ equals 42, but you don't have any equilibrium concentrations at all. Okay, so now that everything's in molarity, okay, when you go to step 3 and you realize that, yeah, I have an initial concentration, the first thing that you should think of is to set up an ICE table. Okay, so I'll go through the rest of the steps here and then we'll actually go through and solve this problem. So once you realize you have to set up an ICE table, you go to step 4 and you check to see again if you have an equilibrium concentration given. If you actually do have an equilibrium concentration given, then you have a type 3. Okay, so you just go back to what procedures you did for type 3. But because we don't have an equilibrium concentration given, then we have a type 4. So if you have a type 4, what that means is you're not going to be able to figure out the change very easily because you don't have any numbers at equilibrium to work backwards. So you're going to have to use an x to represent the amount of change that's going to happen in this equilibrium. Okay. Excuse me. Once you do have the ICE table as filled out as you possibly can, all the other steps are pretty similar to what you saw in a type 3. You're going to use an equilibrium expression, you're going to substitute, and then solve for your desired concentration or goal, right? So in this case here, we want to figure out what our equilibrium concentrations are. Okay, so that is your desired goal at the end. So let's kind of set this up and see how it works. Okay, so whenever you're doing an ICE table, you want to make sure that you have your reactants and products at the top. So we have 2 HBr, 1 H2, and 1 Br2. Okay, so there's going to be 3 columns in our ICE table because there are 3 substances in the reaction. And again, I'm going to make my table a little bit bigger than I usually would. Oops. Okay. All right, so we start off with the initial concentration, which is I. So at the very beginning, we're given 0.1 molarity of HBr. Okay. Also at the beginning, your products, okay, which is H2 and Br2, haven't been formed yet. So if they have not been formed, their concentration is 0 molarity. Okay. The middle row is the change, and the last one, of course, is your equilibrium concentration. So we want to figure out what these equilibrium concentrations are. But here's the problem. This is all the information that you pretty much have. I mean, we could put in the negative signs and positive signs for the change. So HBr is a reactant. It gets a negative sign because we're using up reactant, so it's going to decrease in amount. You're going to create more products. Okay, so when you start off with 0 and you're going to make more at equilibrium, these ones have to be a positive change because you have to create more of them. But again, we don't have any equilibrium concentrations. Okay, and because we don't have any equilibrium concentrations at the bottom here, we can't work backwards to figure out what to fill in. Okay, so this is what we do. We will let X equal the amount of change. So we will say that you have an X here and X over here. Okay. Now, for this one here, for HBr, it cannot just be a single X. Okay, because what we actually have is we have a 1 here in front of the Br, so that's why this is a 1X. You have a 1 in front of the H2, which makes this a 1X. But because you have a 2 in front of the HBr, this is going to change twice the amount compared to the others. So it's going to be 2X. Okay, so it's going to be 2X amount of change. So keep in mind, these coefficients, they all represent the molar ratios and we only use these coefficients in the change row. Okay, we don't use them anywhere else. So when we look at how this affects the equilibrium concentrations, okay, let's start with the reactants. You start off with 0.1 molarity, but it's going to change by negative 2x. So 0.1 minus 2x of change will be the equilibrium concentration for HBr. But because we don't know what x is, we can't actually have a number value. Okay, so this is as good as it gets right now. When you look at the other ones, you start off with 0 and you go through plus 1x of change. So 0 plus 1x is basically just x. 0 plus 1x is x. Okay, so the equilibrium concentration here is going to be the same as the change. Okay, so we can't leave it like this because we actually want numerical values. So what we have done though is that we've finished completing the ICE table as much as possible. Okay, so we are basically just finished step 5. So we move on to step 6. Set up the equilibrium expression and then set the equation equal to the KEQ constant. Okay, so I'll set up the expression right here. KEQ is going to equal your products over the reactants. So we have H2 times Br2 over HBr, but because there's a coefficient 2 in front of the HBr, that coefficient becomes the exponent. Okay, all of that equals 42, because 42, well, technically 42.0, 42.0 was given. So this is a given value from the question. Okay. Now, what we're going to do is we're going to substitute the values from the ICE table into the expression. Okay, so x will go and replace Br2, this x will replace H2, and then this one here, 0.1 minus 2x will replace HBr. So let's just rewrite all of that mathematically. So it'll be KQ equals x times x over 0.1 minus 2x bracket, and don't forget the square, okay, because that was in our original expression, and the whole thing is set up to equal 42.0. Okay, so this is the substituting values from the ICE table. Okay, so now you want to solve for x. So now solve for x. So we're going to do some math. Everyone's favorite. X times x is x squared. Okay. Now I'll show you a little trick here. Okay, because again, this is math, right? I could take 0.1 minus 2x, okay, and basically multiply it by another 0.1 minus 2x. But if you notice that your numerator has a square and your denominator has a square, okay, if there's a square on the numerator and the denominator, what you could actually do is take the square root on both sides to get rid of the square. Okay, so take square root like that. Okay, so this is a very special situation here because you might not be able to do this all the time. Okay, and if you can't do this, okay, then it's not a type 4. Okay, it'll be a type 5, which we'll go through tomorrow. But if you do have squares in both the numerator and the denominator, okay, this is a really helpful trick. So if you can square root if you can square root, it makes the math a little bit easier. So what ends up happening is the square root will cancel out all the squares so that you just have x over 0.1 minus 2x equaling to the square root of 42, which turns out to be 6.48. Okay, so once you have gotten up to here, you will need to solve for x, or continue solving for x, but try cross multiplying. Okay. So when we cross multiply, okay, we know that this value here, 6.48, is over an imaginary 1, right? So these two are going to be multiplied. These two will be multiplied. So what you're going to have is, you're going to have x times 1, which is x, equals 6.48 times 0.1 minus 2x. Okay. So now we can simplify this. Okay. So we're going to distribute the 6.48. So 6.48 times 0.1 will give you 0. Oops. Oops. It'll give you 0.648 minus 6.48 times negative 2x, which is negative 12.96 x. Okay. You still want to solve for x, so you want to make sure that all the x's are on the same side. So you bring this value over. Okay. Now remember, this is a 1x here. So when you bring 12.96 over to the other side, okay, the negative sign becomes positive. So you're actually adding them to make 13.96 x equals 0.648. Okay. Divide both sides by 13.96 to isolate x. So this cancels out, and you get x equals 0.0464. Okay. Now, this x has a couple of meanings, right? So remember, if we go back to our table here, the value of x itself does equal the concentration of Br2 and the concentration of H2. But the concentration of HBr is 0.1 minus 2x. So we have to put that x value in here and then solve for the actual number. Okay, so the concentration of H2 is equal to the concentration of Br2 because they're both equal to X. Okay, so that means both their concentrations are equal to 0.0464 molarity. Okay, but for HBr, it was equal to 0.1 minus 2x. So we will substitute the x value in here. And that will give us a value of 0.0072 molarity. Okay, so both of these values that we have here these are your equilibrium concentrations, okay, that you were trying to solve in the first place. So this particular type of question is considered to be a type 4, but only at this particular point here. Okay, this squaring of roots determines that this is a type 4 question. This makes this problem a type 4. Because without the ability to square root, okay, if you cannot square root here, the math that you're going to need in order to complete this question will require the quadratic formula and the quadratic equation, okay, which is why I say that you have to be careful. Okay, when it's possible for you to take the square root, do it. It'll save you a lot of time, okay, and basically it'll set up for a type 4 type of solution. Okay, if it's not present, if you cannot take the square root, you can't force it. Okay, you can't do bad math. Okay, bad math is just bad math. So if you get to this point here, okay, you're thinking it's a type 4, and then you get to this point and it's like, oh crap, I can't do the square root. It's not a type 4, it's a type 5. And that's what you're going to learn how to solve in the next lesson, in the next video. All right, thanks guys. See you tomorrow.